Balancing DFDs. When decomposing the DFD, you must conserve inputs to and outputs from a process at the next level of decomposition. For example, fruitier burgers. In the image, notice that there is one input to the system, the customer orders. There are three outputs: customer receipt, food order, and management reports. Notice the next image. We have the same inputs and outputs. No new inputs or outputs have been introduced. We can say that the context diagram and level 0 DFDs are balanced. An unbalanced example. Context diagram, level 0 diagram. In context diagram, we have one input to the system, which is A, and one output, which is B. Level 0 diagram has one additional data flow, which is C. These DFDs are not balanced. We can split the data flow into separate data flows on a lower level diagram. Balancing leads to 4 additional advanced rules. Advanced rules governing data flow diagramming. A composite data flow on one level can be split into component data flows at the next level, but no new data can be added and all data in the composite must be accounted for in one more sub-flows. The inputs to a process must be sufficient to produce the outputs, including data placed in data stores from the process. Thus, all outputs can be produced, and all data in inputs move somewhere, either to another process or to a data store outside the process or on a more detailed DFD showing the decomposition of that process. At the lowest level of DFDs, new data flows may be added to represent data that are transmitted under exceptional conditions. These data flows typically represent error messages or confirmation messages. To avoid having data flow lines cross each other, you may repeat data stores or sources/sinks on a DFD. Use an additional symbol, like a double line on the middle vertical line of a data store symbol, or a diagonal line in a corner of a sink/source square, to indicate a repeated symbol. For different types of DFDs. Current physical process label includes an identification of the technology people or systems use to process the data. Data flows and data stores are labeled with the actual name of the physical media on which data flow or in which data are stored. Current logical, physical aspects of system are removed as much as possible. Current system is reduced to data and processes that transform them. New logical includes additional functions. Obsolete functions are removed. Inefficient data flows are reorganized. New physical represents the physical implementation of the new system.